Here are some new photos of 3I/Atlas, the third interstellar visitor ever spotted from Earth, moving rapidly through our solar system. Very far out in the vastness of interstellar space, a dim wanderer has at last been captured in the eye of one of humankind's most sophisticated telescopes. The James Webb Space Telescope has directed its record sensitivity and accuracy against the interstellar object known as 3I/Atlas, taking the first actual image of it since its discovery. This is more than a technical achievement, it is an existential step forward in our capacity to view and analyze material that came from outside the solar system. The telescope's image is not merely a photograph, it is a gateway to comprehending the dynamics of celestial travelers that streak through our neighborhood and then vanish into the blackness, taking with them secrets from far-off planetary systems. When the James Webb Space Telescope initially fixed its gaze upon 3I/Atlas, astronomers were at once struck by the sharpness of detail. Whereas previous devices had been able to show no more than faint smudges or estimates of interstellar bodies, Webb was able to deliver a resolution that rendered its shape and motion visible against the starfield. If this kind of story touches your heart, if you're someone who cares about truth, responsibility, and speaking up for the voiceless, please like this video, subscribe to our channel Spark Science, and share it with someone who should hear it. Let's get started. Its sophisticated infrared capability unveiled a nucleus encased in a spread-out halo, its tail extending into space as sunlight crossed paths with dust and gases shed from its surface. To at last behold this errant object so clearly was to fill a void between conjecture and fact. Scientists had for decades prophesied that numerous such interstellar travelers moved through our system, undetected and unrecorded. But to capture one so clearly as Webb allows is a whole new frontier. The implications of this photograph are far-reaching, beyond the excitement of discovery. 3I/Atlas is just the third confirmed interstellar object following the mysterious Oumuamua and the comet 2I/Borisov. All three guests have presented astronomers with new puzzles and challenges, rewriting theories about planetary origin and the motion of material from star to star. Unlike in those earlier instances, however, the Webb picture offers the most richest data set to date, one that can be interpreted for chemical signatures, surface chemistry, and activity in ways never possible with ground-based telescopes. The chance to compare what has been observed with familiar solar system comets and asteroids will enable researchers to conclude if the formation and evolution processes are universal or if stellar nurseries elsewhere create radically different planetary building blocks. One of the strongest features of the Webb observation is being able to follow the chemical signatures of 3I/Atlas. Webb's infrared detectors can pick up faint emissions from water vapor, carbon-containing molecules, and other compounds that would go undetected otherwise. If the signatures match comets in the solar system's native population, it would imply a type of cosmic similarity, that the same raw materials flow through the galaxy and seed planetary systems throughout. Alternatively, if the spectra indicate exotic or unanticipatable compounds, then this photo may be the first real proof that other star systems make their worlds using disparate recipes. Either way, the data learned from Webb marks a transcendent step toward knowing about the diversity of planetary systems in the Milky Way. Outside of chemistry, the snap of 3I/Atlas trapped by astronomers lets them determine its trajectory and physical characteristics to a degree never before possible. Interstellar objects travel at otherworldly speeds compared to the planets and comets tied to the Sun, and thus are notoriously hard to follow. The Webb snapshot pins down its location so precisely that orbital models can be reworked in order to forecast its passage more accurately. Understanding its precise trajectory through the solar system gives us hints about where it came from, aiming towards the part of the galaxy from which it might have originated. While identifying its place of origin out of the billions of stars continues to be prohibitive, Webb's image serves to narrow down the options, at least providing some suggestion of the cosmic path this piece of matter has traveled over light years in order to pass by our Sun. The appearance of 3I/Atlas also provokes interesting questions about its environments that it has passed through during its interstellar journey. Comets that spend their lives in the frigid outer regions of the Oort cloud, protected from radiation from stars, interstellar visitors potentially have been bombarded by cosmic rays, high-energy particles, and other forces for millions and millions of years. Webb's picture and the information that come with it give us a glimpse of the ways in which this exposure changes the surfaces and interiors of small bodies. Are 3I/Atlas's volatile ices like water and carbon dioxide still present, or were they cooked off long ago? Does it have a tail like those of solar system comets, or is it something quite different, formed during its many years of travel in the galactic medium? These are not theoretical questions, they concern the development of planetary systems and what types of matter endure interstellar space conditions. The visual capture of 3I/Atlas by Webb also speaks to the incredible engineering of the telescope. Located at the L2 point, protected from Earth's light and heat, it works in an environment of nearly flawless darkness, enabling it to perceive the lightest objects on the enormous canvas of space. That it would be able to detect and resolve an object as flighty as an interstellar comet speaks to the prescience of its design. The photo illustrates that Webb is not only used to observe the far universe, galaxies, quasars, and the Big Bang's afterglow, but also an impressive machine capable of measuring near, immediate cosmic events. Its ability to sit astride the local and distant is what makes this so remarkable. The same telescope that looks into the first light of the universe is now uncovering the character of a visitor from another star system. In looking at the Webb photo of 3I/Atlas, comparisons to Oumuamua are unavoidable. Oumuamua was a mystery hurtling through space with no discernible tail and an otherworldly elongated form that resisted simple categorization. Others speculated that it could even be man-made, a remnant of alien technology, but most explanations landed on natural causes. Borisov, on the other hand, acted more like a traditional comet with an observable tail and typical behavior. The Webb picture of 3I/Atlas gives us a third data point in this nascent tale of interstellar travelers, one that will assist in determining if Oumuamua was an anomaly or representative of a wider range of interstellar figures. Observing its tail well delineated, its nucleus shining in infrared, scientists can start categorizing these objects and potentially create an interstellar visitor taxonomy. The cultural and philosophical significance of Webb's photograph must not be discounted either. For centuries, people have speculated if the stars we can see every evening contain worlds similar to our own, and if matter and life are exclusive to our solar system or ubiquitous across the universe. To acquire a sharp picture of an object that coalesced around another star, that wandered through billions of years prior to crossing paths with our own, is to have in hand a physical piece of that extended cosmos. It chastens us to the fact that we are not alone but are part of a vaster canvas of star systems that give and take material across distances of space. Webb's photo of 3I/Atlas is a visual link between here and there, between our sun and this cometary traveler's mysterious home. Webb's observation also has a powerful feeling of urgency associated with it. Interstellar objects have hyperbolic orbits, so they go through the solar system once and leave for good, never to come back. The observation window is short, sometimes only a matter of months, before they disappear into the sea of stars. To have captured 3I/Atlas using Webb before it disappears once more is a rare piece of luck, the result of meticulous planning and global cooperation. It highlights the value of watchfulness in sky surveys and the necessity of prompt reaction in astronomy observation. Every such object could be humanity's one and only opportunity to see matter from a given corner of the galaxy, and the Webb photograph guarantees that 3I/Atlas will not go unobserved into the annals of history. Scientists will spend decades unpacking the information stored within this one picture: infrared spectra, brightness profiles, dust distribution. All these are keys to unlocking 3I/Atlas' story. But already at first sight, the image has done something impressive. It has captivated the imagination of the public, compelling people to look up and outward, reminding us that the universe is not a passive background, but an active stage upon which material from remote systems can suddenly appear in our sky. The James Webb Space Telescope has again served its purpose as a scientific tool, but also as a gateway from the known to the unknown. The first confirmed photograph of 3I/Atlas taken by Webb has already become a point of focus for scientists and hobbyists alike, not only due to its novelty, but because it has shed light on entire divisions of investigation that had hitherto existed only in theory. The instant that Webb's instruments homed in on the object, humankind entered new ground in the discovery of interstellar material. What is most remarkable about this development is not the image itself, but what it signifies, a huge expansion of our capability to research objects that are not bound to our own sun and could have had beginnings in surroundings radically different from the one in which Earth and its nearby planets evolved. Webb's observation of 3I/Atlas directly confirmed the telescope's ability to operate at the limits of sensitivity. Interstellar objects are among the dimmest and most slippery targets available. But Webb's infrared eyes saw past background noise to pick out the comet's shape. This photograph is proof of principle that, given the right combination of circumstances, interstellar travelers can be not only seen, but extensively examined. The technical triumph is incredible. To aim such a delicate device at such a small body traveling so fast through the solar system is like snapping a firefly as it zigzagged across a football field, while looking through a stained glass window. The fact that the outcome is not a blur but a clear, detailed look tells us just how proficient Webb is at rewriting our knowledge of the small bodies that travel throughout the universe. A lot of the suspense arises from the possibility of learning about the interstellar material diversity. The atoms and molecules that constitute the Earth and even the human body are all products of stars that existed and perished long before our Sun formed. Now, looking at 3I/Atlas, we are observing material that has journeyed separately through space, perhaps for millions or billions of years, only to cross within the reach of our instruments. It is a poetic reminder that the universe is always in motion, and that we too are subjects of that great cycle of matter and energy. Webb's photo of 3I/Atlas is not just a scientific breakthrough, it is a visual representation of cosmic unity.